All right, Mary C. Williams friends, this is Miss Britt here. We are still working on lesson 48 and we are still generating or making equivalent fractions. So yesterday you did this section with Miss Caldwell and then you did 3 and 4 for your independent work. Today I am going to go over numbers 5, 6, 7, and 8 with you. And then your job is going to be to complete 9, 10, 11, and 12, and then send us a photo of your work. But because I don't really have a lot of room here and I want to do a little bit more today, I transferred my problems over here for me to be able to do them on paper. And I did make a mistake up here and up here. I totally forgot my whiteout at school and I do not have any at home. So this is going to be page 96, April 17th, which is a Friday. This is your 7th day of instruction. Okay. All right, friends. So remember, our job is to tell whether the fractions are equivalent. So you were generating equivalent fractions up here, but now we're going to look at these two fractions and we're going to tell whether or not they are equivalent. Now we know equivalent means equal to. So you have two symbols that we can use. We can use yes, they are equal, or we can use they are not equal. So either they're going to be equal or they're going to be not equal. Okay? The reason why I'm doing it on my paper is because I wanted to use some models today to help you better understand this. So these are fraction bars, but they are a type of area model. And I put one hole on the bottom and I put one hole on the top just so that you can see that these fraction bars represent the same size hole. This is one whole. This is one whole. And then we are looking for the fraction 1/4. Well, if I take this one whole bar and I break it into fourths, 1, 2, 3, 4, then I have 4/4. 1/4, 2/4, 3/4, 4/4. I also need to break that same fraction bar into twelfths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here I have 12 twelfths. And you guys learned for the last 2 days that anytime you have a fraction that has the same numerator and the same denominator, that equals one whole. 1/4, 2/4, 3/4, 4/4. 4/4 is the same thing as one whole, which you can see that now. And then here, 12 twelfths, if I have a 12 as the numerator and a 12 as the denominator, then I have one whole. 1/4, 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12, 10/12, 11/12, 12/12. All right, so I'm going to get rid of the one hole on the top. I'm going to get rid of the one hole on the bottom. And then I'm going to make these fractions. I need 1/4, 1/4, and I need 3/12. 1/12, 2/12, 3/12. Well, when I look at that, I can tell, I like to use some of the other fraction bars to help me line everything up because remember, your models have to begin and end at the same point and represent to see if they are, they have to begin at the same point to see if they're going to be equivalent. So when I look at 1/4 and I look at 3/12, they are equivalent. Now, your job is to think about the relationship. 1 times what number gives me 3? Yes, 1 times 3. If 1 times 3 equals 3, then whatever you do to the top, you have to do to the bottom to get an equivalent fraction. 4 times 3 is 12. Is that true? Yes. So 1/4 must be equivalent to 3/12 because 1/4 times 3/3 equals 3/12. These two fractions are equivalent. So inside of my box, I'm going to write equal to for them being equal. All right, friends, so let's do that with another one. So I went ahead and got out my fifths because this is broken into fifths. So I got out 1/5, 2/5, 3/5, 4/5, 5/5. I also got out my tenths, 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. So I got out my fifths and my tenths, and I just put the one hole on the top and the one hole on the bottom to show you that these are representing the same size whole. Get rid of that. And now I want to make these fractions 4/5 and 5/10. 1/5, 2/5, 3/5, 4/5. Get rid of the fifth one. I want to make 5/10. 1/10, 2/10, 3/10, 4/10, 5/10. I'll get rid of those. Now my question is, are these two fractions equivalent? Well, I can look at these two area models and I can say without a doubt that these two fractions are not equivalent. It appears to me that 4/5 is greater than, this much greater than, 5/10. So are they equivalent? No, they are not equivalent. Well, how can I prove that? Well, I can prove that because I can find a relationship, or if I can't find a relationship with the numerators, I need to check the denominators. Is there a relationship between 4 and 5? Can I multiply 4 times something and get 5? No, I can't. Can I multiply 5 times something and get 10? Yes, I can say 5 times 2 is 10. But if I go up here and I say 4 times 2, does 4 times 2 give me 5? No, it does not. 4 times 2 gives me 8. So this is a not equal pair of fractions. This fraction is not equal to this fraction. I could make an equivalent fraction. I could come over here and say 4/5 times 2/2 equals 8/10. So 4/5 does not equal 5/10. 4/5 equals 8/10. And I could prove that with my area model. 1, 2, 3, 4, 5, 6, 7, 8/10. Make sure they're lined up to show that they are equivalent. Whoops. And yes, that is a fact. This is true. These two are equal. 4/5 does equal 8/10, but 4/5 does not equal 5/10. All right. All right, friends, so for the third one, I have my models up here, but I am not going to rely on them because you may not have models. So I am going to think about the relationship, but I'm also going to make my own models because I think it is very important for you to use some type of modeling to prove your work. So I'm going to start with 3/8. Now, I've told you multiple times, your models have to be the same size. If I am talking about 3/8 and I'm going to compare it to 2/6, then I need to make sure that I start with the same size whole. just like up here, this is the same size whole as this is. So this is one whole broken into eighths. This is one whole broken into sixths right there. All right, so I'm going to start with I always like to use rectangles when I do area models. It doesn't have to be super big, but it does have to be big enough for you to work with. So 3/8 is what I'm going to make here. Now I need to cut this into eighths. 8 is an even number, so I'm going to do my best to cut it in the middle first. What number plus what number gives me eighths? Has to be the same number. Right, 4 plus 4. So 4 is an even number, so I'm going to cut this in half first, and then half again and half again. So I have 4 on this side, I need 4 on this side. Check your work. 1, 2, 3, 4, 5, 6, 7, 8. Yes, I have cut this rectangle into eighths. Now I need to make 2 6. My rectangles have to be the same size because your holes have to be the same size that you are comparing. Now the pieces inside are not going to be the same size because this has a denominator of 8 and this has a denominator of 6. So this 6 is an even number, so I'm going to cut it in half first. I always ask myself if it's even, so I can cut it in half. What number plus what number gives me 6? And it has to be the same number. Correct, 3. So I need 3 over here and 3 over here. Now 3 is not an even number, so you have to kind of figure it out with your fingers and do the best that you can. All right, now my job is to shade in the fraction. So this is 3/8. I need 1, 2, 3/8, and this is 2 6. 1, 2. Ooh, super close. Now this is a time where you might run into a little bit of a, did I make my sizes as accurate as I possibly could? Well, if I look really close, it looks like 3/8 is a little bit bigger than 2 6. So I'm going to come up here. I'm going to use these to prove it. 1, 2, 3/8. 1, 2, 6. Which one is greater? Yeah, not by much, but it is greater. So 3/8 is greater than 2 6. So are they equivalent? No, they are not equivalent. Well, how can I prove that if I don't have these fraction tiles or these fraction bars? I can come up here and do what we've been doing. We have been generating equivalent fractions. So is there a relationship between 3 and 2? No, you would have to divide, but still you're not going to get a relationship. So start over here with the smaller fraction. 2 times something. Does 2 times something give me 3? No. Does 6 times something give me 8? No. I cannot find a relationship between these numbers. If you started on this side, you would have to ask yourself, 3 divided by something. Is 3 divided by something going to give me 2? Is 8 divided by something going to give me 6? No. So this means that these two fractions are not equal. All right, let's do the last one, and I'm not going to use fraction tiles because you guys may not have fraction tiles at home. So I'm going to just look at it from a relationship standpoint. 3/4 and 6/8, are they equivalent? Yes or no? That is the question. Equivalent or not? I ask myself, 3 times something. Does 3 times something give me 6? Yeah, it sure does. 3 times 2. 3 times 2 gives me 6. So then I have to ask myself, if I say times 2 up here, I have to say times 2 down here. And if this is true, then they are equivalent. Is 4 times 2 equal to 8? Well, yes, it is. So that must mean that 3/4 is equivalent to 6/8. Excuse me, to 6/8. Now, I said I wasn't going to use fraction tiles, but I just would like to show you 3/4 and 1, 2, 3, 4, 5, 6/8. Make sure they are lined up. Are they equivalent? Yes, they are. They are the exact same size. 3/4 is equivalent to 6/8. All right, my friends, on your paper, you would need to put 3/4 times 2/2 equals 3 times 2 over 4 times 2, which is 6/8, which means that these two are indeed equivalent. All right, my friends, if you have any questions, please send us a message.